So how many people here know what Einstein Intent is? You guys familiar with it? I'll just explain a little bit then. It's kind of a general purpose natural language processing classifier. They market it for like sales and service use cases, like routing billing inquiries, to the right department, or case lead routing, things like that. But you can actually use it for almost anything you can come up with. So if you think about in Salesforce, a lot of times you have like a status or a stage, and maybe you have a whole bunch of text that you want to use to kind of predict that status or stage. That's kind of a good use case for this. So I'll show you some examples, but that's kind of to get started. So just to take one step back, they've kind of introduced some new features and kind of changed the umbrella a little bit. So this is the current structure on how this thing is branded. So right now we have Einstein Platform Services. It's divided into vision and language. Vision has the image classification and the object detection. And language has sentiment and intent. And these are very similar. And I think intent is a lot more interesting because it's kind of like, sentiment is more like a limited version of intent. Sentiment is like, positive, negative, neutral. Intent is you get to define whatever categories you want. And that's what I'm going to be talking about tonight. This one here that's underlined, Einstein Intent. So in order to use this, there's kind of a couple pieces to access the APIs. There's this one-time thing you have to do. You have to sign up for Einstein Platform Services, and you have to download this RSA Private Key. And then periodically, you're going to have to create an OAuth token. And this is the JOT flow where it has an expiration. It's kind of a simplified flow, but it does expire. So you will have to create that over and over again. The way it works is you actually use your private key that you download to sign a request to create this token. So just kind of two pieces to the authentication. We'll look some more at that in a bit. To sign up for that token, you go to api.einstein.ai/signup, and you'll see you can sign up either with Salesforce or Heroku. And once you do that, you can download this private key. And this is this one-time thing, so don't lose your key. Once you have the key, this is the JOT token, this payload that you create. So you put a few pieces of information in here, this expiration time, and then you sign this with that key that you downloaded. This is kind of what a request will look like to get an OAuth token. To sign it, it's a little bit of a process. You can use, in Apex, you can use crypto libraries to do that. There's depending on what platforms you're using to authenticate, there's JavaScript libraries, things like that. But thankfully, the Einstein folks have provided us this little cheat way to get a token. So if you go to api.einstein.ai/token, you can upload your private key, give it some expiration, click get token, and it just creates it for you. So this is great for like proof of concepts and just developers messing around. So that's the pieces to authenticating. Every request you make to the Einstein API needs to have one of these tokens in the authorization header. So the first part of the Einstein Intent API is you need to give it a data set. So you can feed it something like a CSV or a TSV, and what we're doing is we're going to give these actual categories for different subjects that have come in. These things came in, and we're saying, oh, that was a billing request. These things came in, I'm saying it was a password request, and then like these come in, we say that's shipping. So these are actual things. And the artificial intelligence is going to use all these actual things that have been classified. And when new things come in that it hasn't seen before, it's going to predict how to classify them. So this is kind of the first step is getting this data set that we're going to train. So you can do it in the CSV, TSV format, or you can use JSON. Maybe this looks a little more intuitive. You have this kind of root property called intents, and there's all these properties for your different categories. The terminology they use in Einstein, they call these here labels, billing, password, shipping info, labels, and they call all these different sentences here examples. So you need this structure. It doesn't matter if it's the CSV format or the JSON format, but you need that data set to get started. They actually provide a couple different methods for uploading. They provide synchronous and asynchronous. So if you have smaller files, maybe you want to use synchronous. It'll respond when the file's fully uploaded. If you have large files, you can do asynchronous. It'll give you a data set ID right away, and you can just pull for the status till it's succeeded. You can also do a local upload or a remote URL. So you can post the file directly with multi-part form encoding, or have it sitting on, like in a cloud somewhere, Dropbox or some other URL. And you can also have all these formats. So all these different combinations, there's like 12 different ways you can get a file into Einstein to build that data set. All right, so that's a few slides. Now let's get into some demos here. Any questions so far? No? It's kind of precursor information there.
Screen's winning.
Okay. So I hacked together this little Lightning app. And what this is doing is it's polling some of these Einstein APIs. So they've actually got great documentation. And you can see here's the different APIs we have access to. So there's an API here for get all data sets. There's an API here for get all models, get training status, get model metrics. So what I've done is I've called these APIs and kind of rendered this API, this UI. So here's our OAuth token and our private key. So we're authenticated. It's called the APIs. We have a data set here, 75 examples, 3 labels. We've got 2 models, and they're both succeeded. You can see some stats, test accuracy, training accuracy. So this just gives us some visibility into what's kind of sitting on the Einstein servers in terms of our data sets and our models. So now let's play with the API a little bit. So what I've done, if you look at the documentation, they've got all these curl examples on how to use the APIs. So I'm just going to go through here and take a look at that stuff. So, we've got this example file they provide. This is the long version of what I showed you on the slide, this JSON file. It's got all of our labels, all of our examples. And we're going to create a data set, train it, play with some of these APIs. So to start with, we're going to do this multi-part form post with the actual JSON file and create a data set. So we're going to post this weather.json file to create the data set. So you can see it's sitting here waiting for the response because we did the synchronous method. You can see succeeded. We could inspect this whole JSON, but it's not that interesting. And if we go back to our little UI here and refresh, we should see here's a second data set that we just stuck in here. So 3 labels, 73 examples. So if we want to query just to see what data sets we have, you can see this was an HTTP post. Here's an HTTP get. Actually, I think I'll call this one instead. This gets all data sets. So we'll see a list of all of them. So, what we got here was a list of all these things. I think I will... This one may be worth showing you. You can paste this into your favorite JSON pretty print tool so we can actually see what's going on here. So this was the get datasets method. You can see it returned our 2 datasets, the one that was already sitting in there and the one we just added. So some basic information about it. We can also delete a dataset, so it's worth a try. Let's go ahead and delete it. If we come back here, refresh, it didn't delete. I think probably I need to copy the ID, paste it in there. Yeah, it's something different. And then if we come back here and refresh, it's gone. But we probably want to actually have a data set that we can play with. So maybe I'll add it again. Okay, so there's our data set. We added it, queried it, removed it. So what else can we do? We can train the data set. We can add more examples. So, we uploaded this data set with 3 labels, 73 examples. Perhaps we forgot some examples, some new ones came in, something like that. We don't have to reload the whole data set. We can just incrementally add a little bit to it. So this has a label with 1 example, and we just want to add that. So if we want to do that, we can do this create examples from file. It does another multi-part form post with the weather update JSON file. So we just need to make sure we have the right data set ID in here. And we can add that 1 example to that existing label in our data set. So this is 73. It should say 74 if we refresh. In theory. Perhaps. Maybe my token expired in mid-demo. I think that's what happened. All right, well, let's get a new token. I created this token this morning, so. I don't know, maybe Einstein's down right now. Let's try the curl again. No, it's working. So perhaps this thing's not working right now. It's okay. We can continue forward with these curl commands. So if we were to query that one, it would have seen the additional example being added. So let's go ahead and train a data set now. So what I'm going to do is grab, since we can't see it in my UI, I'm going to just grab this JSON and we'll pull it out of here. So here's the data set, and you can see it has 74 labels. I think that's what we were examples. That's what we were expecting. We can grab the ID of this thing, and we can actually create a model. So the initial train, there is no model ID to give it. You just give it the data set ID. Thank you. All my tokens are wrong now. So you can see it's queued. We can actually, pull for the status of this, but it does take a little while, so I probably won't sit here and wait for that one to finish. You can also retrain an existing model, and this one, instead of giving it the data set ID, you give it the model ID. So, as you add incremental data into your data set, you can retrain the model, at some interval after you've done that. So we would actually have to query, what we could do is we can get this data set, which already has a model, and we can get the models for that data set. So we have this model ID here. If we wanted to retrain that model, we could put that model ID in here. Get our new access token, OAuth token. And we could retrain that, so it's queued. So I think if you guys want to hang on a second, I can, well, actually, let's just try this again. It's actually a Heroku app. I'm hoping it would restart itself. There's a Heroku proxy running on this thing. No. Okay, I won't take time to restart it. So an important piece of this is your model may not be perfect to start with. They give you a mechanism to create feedback. So what you can do is you can do a prediction, and it might tell you, you might say something like, is it snowing in Denver? And it might tell you, okay, you're asking about the current weather, but maybe this is actually more of a 5-day outlook. So you can actually improve your model by changing the label here. So this is similar to adding data to the data set, except you actually specify a model ID instead of a data set ID. And it does actually go back and update the data set. You'll see an additional example put in there. So the coolest part of all this is doing the final prediction. So I think I'm going to show you that. Yeah, I apologize for that. I think it's just a lot cooler to see through a UI than through command line, so I wanted to restart this thing. So, you know, the punchline for this is to be able to actually run a prediction. So, you know, I just added something that lets you do a prediction request here. So, you know, this thing is trying to predict some weather inquiry. So we could put something in here like, is it raining in LA? And see, you know, how does it classify this thing? Okay, so what this is telling us is there's a 43% chance that us asking, is it raining in LA, is a request for an hourly forecast. There's a 32% chance it's a request for a 5-day forecast, and there's a 24% chance. What is that last one? Anyway, you know, the idea is you can use some natural language in here to say things that have like similar meanings, and it can kind of glean what that meaning is. So, you know, I don't know, maybe if you put in Los Angeles, it would still give similar results, these types of things. So that's pretty cool. Even more, if you're a geek, maybe even more interesting than seeing the actual predictions is like looking at the model stats. So this is kind of a busy UI here. But let's see. This thing's still running. When this is finished, it'll probably take about 2 more minutes. We'll actually see some individual stats on the model. I don't know. Maybe we can get lucky here. Okay, great. So some of the things about this. So first of all, we can see there's a test and train split. So we fed it 75 examples. It kept 18 of those for training or for testing data and used 56 for training the model. So by doing that, without even us having to feed this thing predictions, it can tell us how good our model is. So that's really cool. When you're building models over and over again, try and get them as good as you can. To be able to see numbers and compare them without having to give it any real test data, that's pretty huge. Another thing you can see is you get this test accuracy and training accuracy. So the test accuracy is the most important one. I would maybe ignore this one. I think it's kind of a nuance that most people don't need to worry about. But the test accuracy is saying that overall our model is accurate at predicting 44% of the time, kind of thing. So not that great. You're better off flipping a coin in this case. But, so I've also got even more detailed information. So if we look at all these APIs, we can get training status and model metrics. So using these APIs, I've stuck them in the UI here to where we can see these more details. So what we can see is each label in the model, hourly forecast, current weather, 5-day forecast. We can see an F1 score for each label. So you want this to be as close to 1 as possible. And this kind of gives you a quick glance, whereas this is the quality of the model overall, the training percent, test percent. This is the quality of that label. So we're pretty good, or at least we're about twice as good at predicting hourly forecasts as we are current weather. And then we can also see this confusion matrix. That's even more granular. And probably nobody here knows what a confusion matrix is, so I actually made a slide for that. I'll show you guys that to explain that some more. But so for Dreamforce, I'm doing a presentation with real customer data. For this demo, I'm just using the example file. But with the real customer data, I built a lot of these models the confusion matrices just like go off the screen. There's like hundreds of values in them. And I've been looking at all these F1 scores and improving the model. And the way you improve it is by data prep. So I can talk some about that. The way you transform the data from Salesforce, to make these CSV files or JSON files really influences how your model turns out. So, while I'm still here in API land, you guys have any questions? There's a finite set of these APIs. Basically these here. Are there any that you guys have played with that you have any questions on, or any that you want to see that we can do a curl with? Or? Sure. Do you need a mic? Let's do one.
I saw you had a couple APIs there. One was get feedback, and then
Yeah.
the incremental update one. What's the sort of the difference between those? They seem to do the same thing.
Yeah, let's take a look. So this is the create a feedback example. Yeah, they are very similar. And actually, if you look at the documentation, so the feedback, the feedback is kind of the context in which you're using it. The feedback is like, I just did a prediction. I don't think it's that good. I want to tell you what would be a better prediction for this given example. Whereas the data set, like maybe you don't even have a model yet. Maybe you're not even doing a prediction. But if you look at the documentation for feedback, it says you pass in a model ID, but the example is added to the data set. And so the one where you're adding an incremental thing to the data set goes right into the data set. So I'm sure there's some more nuances about how this influences the model, but they don't really document that. They just tell you it passes it through to the data set. But yeah, sure.
Daniel, you showed us where you did a query and hit submit, and it gave you that UI where you entered the question and submit, and it gave you the result. And the result was sort of a metadata JSON or whatever format.
Mm-hmm.
To take that up to a user, how would you then express that and translate that into something that would be user consumable at an app?
Yeah. So you have your choice. It's a JSON payload. We can see I can show you in command line, but basically this is what you get. So you pass it some question, like this is very similar to what I passed it through the UI. What is the weather in Los Angeles? Go a little bigger. And what you end up getting back is an array of probabilities, and it's got the best result first, next, last. You can also tell it some things like how many results you want it to give you. So if you only care about the top result, just pass in a 1. But the idea is you have to parse this JSON response somehow and put it into UI. At Dreamforce, I'll be showing a demo where I actually do that. What I've done is I've parsed this, and in Salesforce CPQ, I actually use these results to create product line items on a quote. But it just depends on your use case. I think you can do either Apex, parsing of JSON, which is slightly painful, or you can do client side. Like if you're doing Lightning, you might want to do it in JavaScript.
Cool. Thank you.
Okay. I have a couple more slides, but I wanted to answer any questions while we're in API land still.
I have a silly question. So about the nomenclature of the model and a data set, can a model have more than one data set? Can a data set feed more than one model? How do they relate?
Yeah, that's a great question. The sort of default way is you have a data set that can have one or more models. But there actually is, and if you delete the data set, the models go away. But there actually is something, I don't see it, I've seen it before, It's not that easy to find, but I know there's something in here about a global data set also. Does anybody know about the global data set? I haven't worked with it yet. But in general, the most typical way you work with it is it's a one-to-many from data set to models, and kind of has this cascade delete when you delete the data set.
Well, I mean, but then if you have one data set, then how do you get different models from it?
Yeah, so this train a data set, you can call it multiple times with the data set, and it'll create a new model. You know, you can put some parameters in here. You know, why would you want different models for the same data set? So you can put these different training parameters in here. So you could have one model that maybe is a quick and dirty model. It doesn't do as many of these epochs, or epoch, however you say that. And you know, maybe you want to have a bigger train split ratio. You know, you want to put more data in your training or more data in your testing. There's not a ton of differences between the models, but there's some minor differences if you wanted to make multiple versions.
Thank you.
Yeah, really, if you want multiple models with meaningful differences, you probably want multiple data sets that have been transformed differently. Yeah, Jess? We can have one in the front and one in the back.
On the establishing relationships and improving your model, you've got your data set, you've done your training, and you've added more to it. I'm assuming that the feedback is the part where you establish the relationships between, oh, this does mean the same thing as that? Or is that someplace else? Is the feedback something else and I don't quite understand it yet?
Maybe you could phrase that a little differently. I'm not sure I quite got the question.
When you, okay, my experience is more on
Very good.
the Watson tool set, but it's pretty much the same thing.
Yeah.
When you have a data set and you've got a model and you're going to improve it now, you go back through and you establish relationships between, we said this, oh, but it actually means the same thing as that. And I believe that's what is the feedback
Yeah.
about.
Yeah.
Is that what?
Exactly. So the feedback actually contains those two properties which establish the relationship. So, you know, the thing they call it is document and expected label.
Right.
So then that kind of joins them together. So the document, you know, I through most of Einstein, they call these things examples. In here, they call it a document, I guess, because the API is a little more generic. But document would be your example. Expected label would be the label.
Thanks.
Okay, thanks. Yeah,
Another question.
we need a runner.
Someone else back there.
Oh, we got another one too? Okay, go ahead.
I just saw your example. So it's giving us positive, negative, and neutral feedback. So when you just give that API call, and if you get the response as these three, what you'll show to the user? Like based on the higher probability percentage you show to the user as answer, what will be the answer for the user?
Yeah, I think it depends on your use case. You know, you mentioned the sentiment, so I don't know. If it's an overwhelming yes, you probably just want to show yes, but if it's you know, on the fence of yes and neutral, maybe you want to indicate that. In our case, in the case that I've done, I'm actually doing predictions of products for like add-ons and upsells. So in that case, you would want to show multiple ones because AI is not perfect and you can have some human interaction on top of it. Maybe you actually know that this one that had a 57% probability is better than the one that had a 60% probability. So you might want to show like anything over 50%, or, you know, depends on your use case, what you think would be good. It'll return the matches and the probabilities. You can put a limit on it, and then you can add extra logic on top of that in terms of what you want to show the user. Okay.
Yeah, following on with that question in
Oh,
terms of the way
okay.
to put this to use, I'm thinking in terms of, you know, when you go on a customer support site, you type in your question, it refers you to a document, and then at the bottom, it's got the, was, oh, I'm sorry. At the bottom of the page, it says, was this helpful, right? The yes or no.
Yeah.
Is that the sort of thing that you can tie
Yeah.
into the feedback?
Yeah, that's probably what they're doing, is they're putting the users to work, crowdsourcing it for the feedback. So, yeah, basically I've done the same thing. In my demo, it recommends a set of products, and it says, here's what you should upsell them, and you can say, actually, this would have been something better to upsell them. But same idea. If you're saying it's helpful, you're somehow adding more weight to that it's good. If you're saying it's not helpful, if it's a yes/no thing, maybe just train it with the inverse. But it can be complicated if you're classifying many categories and you said it's not helpful. Well, what is helpful, So,
But on an application basis, building that sort of feedback loop into it,
Yeah.
so it's constantly retraining,
yeah.
that would be the idea, right?
Yeah, so some of these models aren't very good out of the gate, and that's your only hope to make them better is through that.
So, sorry, take up time here. You gave me a good framework for sort of understanding how this fits together, that you train it using kind of hypothetical queries and a label to match it to.
You actually train it with real data.
Real data.
Ideally, yeah, you would go through your database and you'd say, I'm looking at all my billing cases or something, and here's all the subjects from them, and you just throw that in.
And then you map that to a label that will help classify it.
Mm-hmm.
And I'm kind of thinking kind of the broad picture in Salesforce, sort of where Einstein grabs all your emails and all your calendars and all your records and kind of consumes massive amounts of data. How do you how do you classify that? How do labels map up to those things to arrive at something that's usable in
Yeah.
this type of structure?
That's where you get to be really creative and innovative. So the example, you could give me a use case and I could try to tell you, but the example I did with the products, I had like a product family that allowed me to identify which products were sort of add-ons and upsells. And I found those and I kind of split my data in half, and I said, my independent variable is going to be my upsell, my dependent variable is going to be all my core products, and there's a lot of opportunity to transform your data. You might have hundreds of things that you're distilling down to like 5 labels. It doesn't have to be a stage or a status. It can be like all one set of records, and you just bucket some of the records into different buckets based on some other criteria, and then make one set labels and the other set examples. I think that's what's exciting about the Einstein Intent API is they've marketed it towards some limited use cases, but I think there's far more potential for innovative ways to use it. So I guess I don't have all the ways, but if we were all to sit around and brainstorm for 5 minutes, I'm sure we come up with some cool ones. Is that answers?
Yeah, kind of.
Yeah.
I mean, they've got hundreds of data scientists that
Yeah.
spend more than 5 minutes figuring this stuff out,
I've-
and they've been doing it for years.
I've got a slide on it. Your examples need to be text, like language, but your labels can be like Salesforce IDs too, so you can do some interesting stuff there. They can only be up to your labels can only be up to 180 characters long, so you got to be careful there. Your examples can be pretty darn long. I've done some huge ones, but they do take exponentially longer to train as you get longer examples. It can be the difference between like 2 minutes or half an hour if you put like 10 words versus 4 paragraphs, that kind of stuff. So.
But I would assume if you're like integrating into, say, a Force.com app, I mean, labels would be good, pick list values would be good, record types. So,
Sorry. Yep.
should I actually repeat that, or?
Yeah.
Okay. That if you're, say, integrating into, say, Force.com app, candidates for things to map your labels onto would be pick list values or record types or, anything that's a way of categorizing records.
Yeah, I think especially things that you spend a lot of time doing. You know, build those efficiencies. If you're spending a lot of time reading stuff and putting it in a category, then this is a great fit. Okay, we can always come back to APIs if you guys have any questions. But I got a couple more slides here. All right, so I kind of explained there's these three different sort of parameters that tell us some different accuracies of the models, different granularities. I kind of explained the overall one. We have this train and test. You really want to focus on the test. That's the most meaningful to figure out the quality of your model. You want to get that as close to 100% as you can. And there's the F1 for each label. You want to get that as close to 1 as you can also. But then there's the confusion matrix, which is even more granular. So this doesn't show you just the F1 for each label. It shows you all the relationships between all the actual and predicted items. So in our case, we had something like weather being a daily forecast or weekly forecast. But here we have like cat, dog, rabbit. So this confusion matrix is saying that an actual rabbit was predicted 11 times. A dog was predicted as a rabbit once, a cat was predicted as a rabbit 0. So ultimately, where these intersect, you want really high numbers. So, actual and predicted all the time. The wrong actual and predicted not very often. And so you can see this model is very good at predicting rabbits. It predicts them way more often than it miscategorizes them. But dogs and cats aren't as strong. So you can see the actual dog predicted 3 times. It also predicted as a cat 3 times. So kind of the quick glance is you want really big numbers going diagonally where they intersect, and you want really small numbers where it's kind of mispredicting. So it's kind of fun to look at these things, and you can almost find ways to clean your data by looking at this stuff. Like sometimes taking a product and deduping it can clean up some of these things to help it classify it better, things like that. It's kind of it's a lot of detective work, but this data prep step is kind of where we get to add the value. The AI stuff we don't get to do a whole lot with. That's provided for us as a service with a few options, but I've put some of the stuff that I've learned, some of this the hard way. So, clean, combine, reclassify, deduplicate your examples and labels. I saw huge differences in the testing quality of the model. So I was able to move it from 40% to 60%. Just by removing numbers from products, which kind of smashed down and deduplicated them. So the model worked way better if it was a 10 by 10 tent and a 20 by 20 tent. If I just called them both tent, the model got way more accurate, things like that. So you need at least 5 examples per label. And if you have duplicate examples, they'll only be added to the first label. So this is a big gotcha when you're using this. You might think that you've got all these labels with 5 examples, but when you upload the data set, it might actually fail because it only counted, if you have some duplicate examples, it's just going to stick them in the first label, and then your next one will only have 4. So you need to do this step on your own before you upload the data set. Your code actually has to and this can get pretty complicated because, which one do you want to pull it out of? You get to choose that. So you might want to write an algorithm that takes the ones with the most examples and dedupes by taking away from those, so you end up with more labels. Otherwise, you have more labels that drop out because you're pulling all the examples out of all the ones that drop them below the 5 threshold. So, there's different ways to solve this. You can also just add some unique piece of entropy, which is putting a little garbage in your model, but gives you more unique stuff. It doesn't have to be entropy. It can be multiple values. Like maybe you want to throw like the customer's industry in there along with their product to get a unique value, something like that. I mentioned the 180 characters. They don't need to be words, so you can actually, your examples have to be words because it's doing natural language processing, but your labels can be Salesforce ID, number, whatever. Yeah, so that's it for what I have. You guys have any more questions? Yeah.
Sorry, I just had a couple questions. So
Oh, you got one.
You mentioned the words that are inputted. Are those real sentences, or should we pre-process them into keywords?
I think I've had good luck with both. I think it says in the docs that only English is supported, so I don't know exactly what that means. Like I noticed actually had better luck with fewer punctuation. It's just, you know, like it seemed like keywords seem to be better for me than long sentences, but I think this product is made more for long sentences, so I think that's a bit of the black box that you kind of have to find through trial and error. But that's kind of what I've found so far.
Got it. And then the example you gave of the project you're working on where you're giving product recommendations.
Mm-hmm.
Can you give us an example of what sort of data you use to train that recommendation? Are you using actual natural language from emails, or I'm just curious.
Yeah.
Is it on the account record, or how, like?
Yeah, so no, I can definitely tell you. So what I've done is I've split products into add-on and core products, and I'm using the core products as the labels, and I'm using that, I'm using the add-on products as the labels, the core products as the examples, and I'm grouping them at the quote level. So what that's kind of saying that, you know, if all these things were purchased together, then that's kind of the linkage at the quote level. And I'm using like I'm using a version of the product name that's been heavily put on a diet. So it's been basically I've got an algorithm that cuts all the products in half, and that's making for like way more accurate models. So I'm pulling out numbers, pulling out special characters. I'm pulling out actually tiny words seem to help, like 2-letter words, pulling those out, things like that. So I'm sure it's highly data dependent. You know, the industry you're in, your products are going to look different and things like that. But that's what I'm doing. I'm grouping at the quote level, bucketing them based on core and add-on.
So you're not using language in this specific example you're talking about, or are you using the language is the product?
The language is the product. So an example would be, you know, dome window or, you know, tent tablecloth, things like this. So they're like short sentences. You know, like a bunch of 2 to 6 word sentences, 1 per quote line, and then all those put together would be your example. I did try some other things that didn't seem to help. I did try putting industry in there and some things like that, and actually seemed to hurt the model a bit. I was kind of surprised, but a lot of trial and error with the data prep and the data that you choose to prep.
Right, okay, cool, thanks.
Yeah, sure. Yeah, so that's a good chance to plug my Dreamforce session. If you guys want to see this in a real application with Salesforce CPQ.
Are the apps, sorry to hog this, if somebody else wants, just raise your hand. I'll pass it up. But
Okay.
if you do a query against Einstein, can we expect it to come back in constant time? Or I know training can take a long time, but actual queries, is there some sort of expected time that they take?
It's pretty fast. I don't know what the SLA is, but it's generally supposed to be like, you know, real-time synchronous thing. So I think we saw a little latency here, but it was probably just some glitch in the network or something like that.
Okay, cool, thank you.
Sure.
Can I keep asking questions if I can?
Do you know what kind of trailheads are out there around Einstein?
Yeah, I submitted a list of them for this. There definitely is trailheads for all this stuff, and depending on how deep you want to go into it, you know, down to the lightning level or the apex level. You know, I think I found about 15 relevant sessions, you know, Salesforce CPQ and everything like that. So
And these are all in trailheads?
Trailhead. Yeah, I don't have the list handy, but Salesforce requested the list, so I think they're going to do something with it.
Cool.
Maybe they added it into the agenda builder?
Session description.
Yeah, okay.
In the session descriptions, they usually suggest that email modules that you can take pre-order after the session.
Yeah, so if you search for Einstein Intent on Tuesday, there's only a couple sessions, and one of those is mine. So
Question?
yes,
Sorry. So about the confusion matrices.
yes.
So the example you showed was 3x3 matrix, but what was shown in the UI seemed more like a vector, like one-dimensional. So what is there? Just are they just compacted or?
Basically, this one just has labels. So this is telling you, you know, what the category is, what the classification is, and this is telling you actual and predicted. Whereas here, there's no labels. It's just the raw data. But you know, we have 3x3 here,
Oh, so it is.
and we have 3x3 here. This is dog, cat, rabbit, and this is, you know, hourly, weekly forecast type thing. But same idea. I could have built out this UI to have this fancy label thing on it, but I didn't.
Oh, I see. And
Yeah, but you can still kind of look. You know, you see we have a 3, a 3, a 2. We have a 6 right here, so it's mispredicting. You know, it's off that line pretty high right here. So
so in terms of performance, I just had a kind of I'm wondering. So it probably isn't a good idea to just let users provide feedback directly, right? Because if there's a million users and they each trigger retraining of the model, then it's gonna get crazy, right?
yeah, that's a whole other engineering aspect. I don't know if you would want an approval stage for these feedbacks, and I don't know what the best practice is for batching up the retraining of the model. But yeah, potentially you wouldn't want to do that real time. You'd want some buffer for quality and performance in there.
Can you execute queries against it while it's retraining?
The question was, can you execute queries while it's retraining? I've tried a lot of things. I don't think I've tried that particular thing, but a lot of stuff like that I've tried, it says no, you can't do this while status is running. I'd have to try that one to know, but you can't retrain a model that's training, things like that. So
You have two data sets going on the same thing, sort of A/B testing in terms of accuracy?
Yeah, so in my demo, I do that. I actually, I've created several models on several data sets, and you get to pick, you know, and you could name them things like, this is my winter promotion or whatever, and maybe they have, it's kind of different data in them. And so you can run your prediction against one and see what you get, run it against another one, see what you get. Is that your question?
Yeah, I was following up on the last question about whether you want, you know, users to have that input or whether you need to moderate it. What you could do is you could have one online data set that you're using, you know, in real life. Meanwhile, you're retraining a second set and comparing, and at a certain point you say, gosh, that one really has gotten a lot more accurate. Let's bump over.
Yeah, no, that's a great idea, and I think Einstein is supposed to be doing some of this for us. I don't know if, you know, these intent APIs are doing it. They're still beta, but I think the vision and the way Einstein has been advertised is that it's doing a lot of brute force multi-model stuff in the background and giving you the one that works the best. Maybe that's more in their sales and service cloud products, but
Yeah, but without you providing it additional retraining information, it wouldn't be able to do that.
Sort of learning in real time.
Yeah, exactly.
Yeah, I think in production that's a great strategy, is to have multiple models, have in various stages of retraining and ones that are ready to use now and things like that. All right. Yeah, we still got 10 or so minutes if you guys want to hang out, ask me questions personally or amongst yourselves. Thank you everybody for coming out.